Okay, so at this stage, we're going to complete the product link list, the actual list that will allow us to link all of these nodes or any objects of these kind of nodes that they themselves have a product as a payload and point to the next node if we start linking. So all the management is going to be done here. So a couple things we're going to be doing is we're going to have to identify one particular node or a reference to a node as the head. Why is that? Because your first node, right? So if you create your first node for the link list based on what we did in part 1, please review part 1 so you can visually see how that works. Its next will be pointing to null, but it in itself as a node will be the head of the link list. When we insert another node, then we're going to move the head to the new one. But the new node will be pointing to the old node. And that's how you build it. Okay? So to accomplish that, let's go ahead and figure out the attributes we're going to need here. Well, we're going to need, as I mentioned before, let's go ahead and do this, private. And we're going to do a product node. We're going to call it head. Okay, so that's a good start right there. What else would we want to do? If we're going to build a list, it probably will be a good idea to figure out what is its length, right? So why? Because this list will be dynamic. That is, when we're ready to run our program, our application, this list will expand while the program is running, and we can also make it shrink while the program is running. So we get to see, we're going to have an add method somewhere where we can add a node and manage how the linking is done. And we're going to have a removal of node based on some condition. Basically, if you have a product ID that matches a certain value, right? Since your product IDs hopefully are going to be unique, all right? So you're going to be deleting that particular node, but we're going to have to make sure that when we do that, we relink our link so we don't end up with a gap, so we can traverse the link. So a key element in the management as well here will be the traversing of a link. So if I'm going to traverse a link, I would like to know how long it is. If I'm going to search a link or a link list, I would like to know how long it is. So I'm going to do this private, and I'm going to do an integer here. It's simply going to be an integer value, and we could call it number of parts, right? Since that's what we're doing, right? So each node in the link list is a particular part, right? Okay, good. We know when we set up our constructor for this, we're going to have to set the number of parts to 0. In other words, the moment you create this linked list, it will be empty in terms of parts. Okay? All right, so if that's true, then we also want to make sure that head as a node is pointing to null. Okay? So it's basically null. All right, well, that sets our game plan for the constructor. Constructors. And I'm going to use 1 for now. So let me just write it up lowercase here, constructor. And remember, I'm writing this on the fly, so I might make adjustments later. But at least I know I want this. Now, the linked list is called products list. So make sure you use this word here for the name of your constructor. So public products linked list, right? So it's a method. And if it's a default constructor, we're not going to put any arguments there. What are the two things I wanted to do? One is make head equal null. Two, right? Number of items in here, or number of parts, be equal to 0. There you have it. So we can actually build, for testing purposes, a products linked list right here. And then eventually we're going to add things to it. So right now, let me go ahead and comment out some of the stuff we've done here. Okay. And I'm going to come here and go ahead and create. So we're testing. So we have two objects here. We're testing here a product linked list. And let's call it my list or my product list, whatever you want to call it. I'm just going to call it my list equal new. And I'm going to use the default constructor, semicolon. Right? I'm going to run this, even though there's nothing really going on. I just want to make sure that I don't have a runtime error. Everything looks good. Okay, so I have not inserted any of these products in the list yet, which means we simply have an empty list, right? So we have the head pointing null and number of parts equals 0. So nothing really going on here. So a few things, a few utilities we may want here, or a few accessors, is to be able to get the length of this thing. So maybe we're going to have, so first I'm going to put mutators here. I'll fill it in. And I need some source of an accessors. And one of the accessors to get the length of this, right? So how do we do that? Well, we'll simply return number of parts, right? So public int, and this will get the number of parts that we have here. And we're going to return number of parts. If we go over here, and if we do a system.out.println and my list dot get number of parts, I should get 0. And let's go ahead and run this thing. And sure enough, we get 0 right here. Okay? So as you can see, it's working the way I want to right now. So let's build it up slowly. So what else can we do? So we have get number of parts. Another one is to look if it's empty. Right? Why? Because sometimes I might want to do a test. So instead of just getting 0, maybe I need a Boolean. If it's empty, that means there's no items in there. I could use that for an if statement. So I could do something related to this, maybe something like this, public Boolean, and is empty. And this method will return true. So we're going to do a return statement. If indeed numbers of parts, numbers, here you go, of parts equals 0. If that's true. So if this is true, this is a condition here. This condition here is either true or false. If this is true, then this will return an empty. So let's test it out quickly. We could do something like this. If, so as you can see here, we're looking at the various things we could use to manage this list. My list is empty. Then we will print here system.out.println. This list is empty. Right? So let's go ahead and run this, and it should say the same thing. So we've got two ways to test. One gives us the length, and 1 gives us a Boolean to double check and make sure that we have an empty list. Fantastic. So I am going to slow down on these explanations in terms, I think I went a little too fast when I did the node. So I'm going to go stop here. We're going to pick it up for the next video. We're going to look at more accessors and mutators and build this one slowly. We're going to be doing testing here every time as we build this list until I'm happy with it. And then we're going to write a real application that could be menu driven to do the inventory control. And then you'll ask the user to actually enter all the parts. It will save them for us. We can remove a part. We can update parts. We can do a whole bunch of things. So, and we can see that the parts list will expand or contract as needed. And that will be part of what our main program will do. But right now, I'm just testing. I'm building it slowly, testing it. So at this stage, as you can see here, we built the list with a default constructor, and it's simply sending it out head equal null, which means we have nothing in there. We don't have a product, right? Or a product node. It's pointing to null. And so we now know when we're ready to insert what's going to happen. And at the same time, the number of parts is 0. So this is because we're using the constructor. This is at time of build. The length should be 0. And also, if I want to do a test, is empty is a good method to use to verify if something is empty in case I want to figure out the length this way. Or if I want to figure out if something is empty and I need a Boolean to do this. Could I have done it is if it's equal to 0? Yeah, you could have done get number of parts if it's equal to 0, do this as well. But I just wanted that capability one way or the other. So I'll see you for the next video.